Okay, so I'm going to go ahead and work through some more problems here on the UDO. So the first one, again, we talked about already, but just in case you were not here, student performed the calculations and read his answer to B, and again, all this decimal point, but the key part here we're looking at is e to the 3, or E3. And again, hopefully you remember that on the calculator, E3, okay, means 10 to the 3rd power. So don't ever write it when you're writing your answers. If it gives it to you in scientific notation, be sure you do write it in scientific notation. Don't write the E value. Okay, so this is going to be doing some mole to particle and particle to mole conversions. And anytime we're talking about, again, reminder, anytime we're talking about the number of atoms, the number of particles, the number of molecules, the number of ions, the number of formula units, the number of eggs, the number of marbles, it doesn't matter what it is. Remember, because there are so many of those, we don't want to have to write out this decimal value every time. So it's easier, instead of saying I have 36 eggs, it's easier to say I have 3 dozen. And that's what this is, because this value is so big, you don't want to have to read off 2.39 times 10 to the 24th every time, when it's easier to just say I have 1.5 moles or 1.3 moles or 2.5 moles. A lot easier to do that. Again, so that's all we're doing. Just remember, we're just wanting to know how many, if I have this many particles, how many moles would that mean? And again, Avogadro's number says that there are 6.02 times 10 to the 23 particles per 1 mole. Okay, now again, remember, guys, that this word particles, that's not set in stone. Again, that's just like eggs. If I have a dozen eggs, I have 12 eggs. If I have a dozen pencils, I have 12 pencils. If I have a dozen calculators, I have 12 calculators, so forth. So this value is just a generic random variable, not random, I shouldn't say that. It's just a generic that can be changed to anything that you're talking about, okay? So let's go ahead and get started then on that. So when I look at this value, 2.39 times 10 to the 24, and I know that is not the best looking at it, but hopefully you have this paper. So already I know that Avogadro's number is 10 to the 23. So I'm probably going to have at least, 1 mole to close to 10 moles, right? Because 10 times 10 to the 23 would give me the 10 to the 24 on that. So, but it might not be quite that. So it's going to be somewhere between 1 and 10. Let's just put it that way. So we're wanting to know how many moles. This is my given. Okay. Now, in this case, since we're not talking about, we're just talking about a count. Okay, about a count. I don't really care what the compound is or the element is or whatever. Now, if I'm doing mass, then I do, but I'm just doing a count, so it really does not matter. But we're still going to put it on. 2.39 times 10, and I use the dot instead of the multiplication, just because I think it's easier. And again, this is particles of NaCl. And so again, to make some of you guys happier, I will put a railroad track in here, and I want to know how many moles. So again, particles are in my numerator, so particles must go in my denominator. Okay, and so 1 mole of NaCl is 6.02 times 10 to the 23 particles. Okay, so particles, particles. Everything cancels there. Okay, so the only unit I have left right now is moles of sodium chloride. The rest again becomes just a calculation. I'm going to multiply across. I'm going to go ahead and put that on here For some of you guys, I understand that some of you do not need this and will find it extra work. Just writing, but we'll go ahead and do that. So again, when you go to put it in your calculator, be sure you put it correctly. So probably we've talked about the fact either put it in parentheses or use the EE key. And again, I have the preference of the EE key. That is just mine, but definitely you do it how you want to do. So I'll just show you how I put it in. 2.39 E, because when I hit the EE key, it just puts an E, 24 divided by 6.02 E, 23, and enter. And then there is my number, 3.9700. And remember, we said it would be between 1 and 10. Okay, so 3.97. Now let's talk about digits here. 3, 3. So that answer, I'll come on down here, of 3.97 moles of NaCl. Also, if you are one of those students, and I know there's those, I think I write fairly small, but when I get into doing this, I find out that really I might not be writing small enough. So you are more than welcome. If I don't leave you, you're a large writer, you would prefer to do all of these on blank paper or line paper. I just want them done. I don't care necessarily where you do them. So doing them on this paper is not required. Okay, now this one is switching it up. It says how many particles. So this time I have 4.5 moles. So think about if I had 4.5 dozen eggs, that would be 4 times 12 would be 48, and then 6 more. So I'd have 54. I'd have 54 eggs. So in this case, it's 4.51 moles. Every mole is 6.02 times 10 to the 23. So I would take 4.5 times that. So again, 4 times that would be 24. 5 times that would be 30 on that. But then I'd have to move my decimals. So we're going to have an answer somewhere in there. Again, ballpark it between 24 or 2.4 times 10 to the 24 and 3.0 times 10 to the 24. So see, I already kind of have an idea of what my answer is before I ever work it. So 4.51 moles. And I may have already mentioned it to you, but the abbreviation for a mole is MOL. They just take the E off. It's kind of strange, but it is. So moles here. So moles here. So I always start kind of crossways with my denominator so that I see these crossing out. And so I know the 1 always goes with the mole. The 6.02 times 10 to the 23. And this case, I'm still working with particles. Okay, that's going to cancel and cancel. So this time it's going to be a multiplication, which is what we just talked about earlier. So now I'm going to go to my calculator and put that in. Okay, so I have 2.7. I need 3 digits. And so the 1 is going to, or the 5 will round the 1 up, times 10 to the 24th power. And that is particles of carbon dioxide, my bad. Okay. So don't make this overly difficult. Okay, don't make it overly difficult. So now this one's flipping. How many moles? Well, that number, see that number, it's 22. It's less than the 23 that I have. It's less than that. Okay, here's 23. Here's 22. So I don't even have a mole. My answer should be less than 1 full mole. Okay, so and I figure that I say the word mole. I have to think about it. Mole. Anyway. So here we go. We have 5.42 times 10 to the 22 particles of lithium. I don't know of any abbreviation for particles, but, and so, again, particles are here. So I'm going to put particles. I should have left myself more space. And then 1 mole. Okay, so 6.02 times 10 to the 23. Didn't leave enough space. Okay. Particles cancel. Particles cancel. I'm going to run this. Now this is going to be, again, I don't, on this sheet, I'm doing the railroad tracks. You know me. I don't do railroad tracks all the time, but I'm trying to make people happy. They like the railroad tracks, so I guess I'll give in and do that. So again, put it in correctly. Make sure, oh, I just put a number in wrong. So let me do that again. Again, that's why I like this calculator, because I can see exactly what I put in. Okay, so I get 0.09. We talked about we wouldn't even have a whole one. 0.0900. Now remember, this is not significant, so I need 3. So it's going to be there, and the next number pops up is a 3. Moles of lithium. Okay, and again, always check my multiplication, because there's always a chance that I could have screwed up on there. So just because you do not agree with me does not mean you're wrong. It could be I'm wrong. So just check my, especially if you have it set up exactly as I did. Okay, let's go another one. How many particles? So I'm going to start with my given. So 0.0341 moles of sulfur trioxide. And again, 1 mole of sulfur trioxide. And then again, I want particles. 6.02 times 10 to the 23 particles. And 1 mole, particles of, sorry, I already have the 1 mole of sulfur trioxide. So again, look here, I've got a very, very small number here. So I'm not going to have a full, it's going to be less than 23, right? Because I don't have a full here. So again, let's run some numbers. Try to get this done before kids enter. So 6.02. Okay, so just to finish out this problem then, remember your moles of sulfur trioxide cancel out. We're left with particles of sulfur trioxide. When I took the 0.03, when I took the 0.0341 and multiplied it across, I got 2.05. Oops, I left out my exponent, times 10 to the 22 with all the confusion here. There we go. So final answer. Hopefully that makes sense. And hopefully you'll have fun with the rest of them. Talk to you later.